Hello, welcome to Math Just Got Easier for You. Today's lesson is on the laws of exponents. This is lesson 3. And so we're going to be dealing with zero exponents as well as negative exponents and some more complex problems that we'll be able to solve as well. So let's look at our first law here that we're going to be working with today. Now, the zero exponent law says any number or letter raised to a zero exponent is always 1 is our answer. So no matter what, any number, any letter, any term raised to the power of 0 or to a zero exponent, the answer, the final answer is going to be 1. So let's look at this example. We have x to the 6th power times y to the power of 11. But all of this is raised to a power of 0. And since we know that our law of exponent for zero exponent says any number or letter raised to a zero exponent, it is always 1. So our answer is 1. Let's look at the second problem. We have 7 times y raised to the power of 14, and all of this is raised to the power of 0. So what would the answer be? You got it. It is the number 1. So let's look at your negative exponents. So this says when there is a negative exponent, you must change it into its, let's see, reciprocal in order to make the exponent positive. So let's look again. When there is a negative exponent, you must change it into its reciprocal, and I'll show you what that word means, in order to make the exponent positive. So the rule is we can never have a negative exponents. Negative exponents are illegal in math. So we always have to change it into its positive. And the only way we can make it positive is by using its reciprocal. For instance, if we have x to the negative 3rd power or to the power of negative 3, a reciprocal means if the number is in the numerator, we have to move it into the denominator. So in this case, x to the power of negative 3 is the same thing as saying x to the power of negative 3 over 1. The reciprocal of that means that the two of these, they change places. So now this becomes 1 over x to the power of, instead of negative 3, we're going to make the exponent now positive. So it'll be to the power of positive 3. So now we've gotten rid of our negative by changing x to the power of negative 3, moving it to the denominator. And we move that 1 into the numerator. Let's look at the next one. Here we have 1 divided by x to the power of negative 7. The rule still applies. We have a negative exponent, which is illegal in math. So in order to make it positive, we need to move this x to the negative 7 into our numerator and make the exponent positive, and then move this 1 into our denominator. So it would look like this. We have x to the power of positive 7, now that we've moved it up to our numerator, and this is over 1. And if I would simplify that, because we don't need a 1 in our denominator, because we know that anything divided by 1 is itself. So our final answer is x to the power of 7. Let's look at the third problem. Now we have 5 times y to the negative 6th power divided by 8. One thing that I love to do is I just like to just divide this, okay? So I'm going to have 5 divided by 8. times y to the negative 6 power, or the power of negative 6, divided by 1, because we know that since that's in the numerator, automatically a 1 is in the denominator whenever we don't see anything there. So let's go ahead and look at this. 5 divided by 8, it cannot be simplified anymore. So we're going to keep that 5 over 8. However, this y, the variable, has a negative exponent. We know negative exponents are not legal in math. So in order to make it positive, we have to change it into its reciprocal. So instead of saying y to the negative 6 over 1, we're going to move the 1 up to the numerator. And we're going to move y to the negative 6. We're going to move it down to the denominator so that that 6 can become positive. So that leaves us with y to the positive 6 on top, on the bottom, or in the denominator. And we have 1 that goes on top. So that's 5 times 1. And 5 times 1 is 5. So this leaves us with the answer of 5 divided by 8 times y to the 6th power. Our final question here, we have 3 times x divided by 7 times x to the negative 10. Now, whenever we do not have an exponent, it's automatically a 1. And we're going to divide it like we did before. We're going to just separate those two. That leaves us with 3 over 7 times x to the power of 1 divided by x to the power of negative 10. And there's a rule that we can use here. Whenever we are dividing based upon our lesson number 1, we know that whenever we are dividing with same bases, we subtract the exponents. Okay, so let's do that. So since we have 1 minus negative 10, so let me write this over 3 over 7, and we have x to the first power minus negative 10. Now, whenever we're subtracting, it's the same thing as saying plus the opposite. Okay, so or subtracting the opposite. So we have 1 minus negative 10. So instead of having 1 minus negative 10, we're going to add the opposite. Okay, so that's the same as saying 3 times x to the 1 plus 10. So let me write this. We have 3 times x to the power of 1 plus 10 is 11, all over 7. It cannot be simplified anymore. So therefore, our final answer is 3 times x to the power of 11 divided by 7. Now let's look at our very last example. When solving problems with exponents, once again, as I said before, I like to just split it all up, because we have 15 times m to the power of 3 times t to the power of negative 5, and that is divided by 18 times m to the power of negative 2 times t to the negative 4. So let's look at this. We have 15 divided by 18, and I'm just separating them, times m to the power of 3 divided by m to the power of negative 2 times t to the power of negative 5 over t to the negative 4. So let's start applying rules that we already know. We need to simplify 15 over 18 into the simplest form by finding the greatest common factor. The greatest common factor of 15 and 18 is 3. 3 can be divided into 15 evenly, and it can be divided into 18 evenly. All right? So that leaves us with 5 over 6. So let's go to the second set. So we have m to the third power, the power of 3, divided by m to the power of negative 2. Since we're dividing with the same base, that means that we can subtract the exponents. So that's the same as saying m to the power of 3 minus negative 2. Now remember, whenever we're subtracting, it's the same as adding the opposite. So this would be m to the power of 3 plus the opposite of negative 2, which is positive 2. And that gives us m to the power of 5. So I'm going to put this over here, and it is in the numerator. So it goes up here with our 5. I'm going to extend this line a little bit more. And let's look at this last one here. So we have t to the negative 5 divided by t to the negative 4. Whenever we're dividing with the same base, remember, we have to subtract the exponents. So that gives us t to the negative 5 minus negative 4. Anytime you are subtracting, it's the same as saying I am adding the opposite. So that has t to the power of negative 5 plus positive 4, which is negative 1. Now, before we even include it up here, we know that we cannot have a negative exponent. So to get rid of that negative exponent, we have to use the reciprocal. And the reciprocal of t to the negative 1 is 1 over t to the positive 1, because once you use that reciprocal, you will change that negative exponent into a positive. So that's the same thing as saying 1 over t. So since t is in the denominator, we're going to put t in the denominator here. So this leaves us with our final answer of 5 times m to the 5th power divided by 6 times t. So this was lesson 3 of our laws of exponents. Please make sure you subscribe below for upcoming tutorials as well. Thank you so much.